All right, let's take a look here. So I rewrote it in better form already. Get rid of that stupid O notation. Right? So this is f of x plus 5, right? Because that's what g of x is. Come with it. Bam. And then what do I do with the x plus 5? I plug it in to the f function. So 4 times x plus 5 squared minus 1. And then to simplify this, right? So you get 4x squared plus 40x plus 100 minus 1 is 99. Nothing major. What did I do? X plus 5 squared. Is that hard? No. So I rewrote what that is there. Then I distributed a 4. Is that hard? No. Then I did 100 minus 1. Got 99. Again, every step, simple. You don't have to worry about every step at once. Just do one step at a time. So what part of that is getting you down here? If you square this, don't you get this? Right, got to write it twice, FOIL it out. You can even do that on the side and put the answer back in. And then distribute the 4. And then subtract 1. Okay. I'm not sure which part is giving you trouble. Every single step is easy. I have no qualms saying that.
I just forgot to factor it. Yeah, me too. I forgot to do
Factor it? What do you mean?
I forgot to do the, I forgot to do it times itself.
Yeah, you got to simplify it. I like it. If that was a 7th power or something, I would not make you do that. You understand? But it's just a square. You should do it. All right. So what's this one? G of, what do I do with this thing?
That one is 4 times 4.
So you plug a 3 in. 4 times 3 squared minus 1. Good. 4 times 9 is 36 minus 1, 35. And what do I do with the 35 now?
Plus 5.
Put it in a G, so 35 plus 5, 40. Crazy. Again, people that are good at math are normally the people that come in that are able to already just kind of focus on the one thing you're worried about. A lot of times people that aren't good at math just don't have that built-in ability. You've got to make yourself focus on just the one thing you're worried about. I think a lot of people just kind of see the whole thing, like, oh my God, and then you just realize, no, it's 3 squared. 9, then times 4. That's the only thing you worry about. All right, this guy. What do I do with the inside?
Plug in the negative?
Yeah, negative 1, plug it into F. 4 times negative 1 squared minus 1. So this will be
4 times 1.
4 times 1 is 4, minus 1, 3. And then you just do the same thing because it's in the F again. 4 times 3 squared minus 1. We already did that. Yeah. So just don't make more of this. There it is. All right, there I gave you a couple different functions. Same idea though. This is k of,
We have 1 over x squared.
good, 1 over x squared.
Minus
I wrote that down, right? Yeah. And then what do you do with this?
Plug it in.
Plug it into k, so it'll be 2 times 1 over x squared minus 3. The only thing you really do is this. There's nothing else you can do there. Not really.
Okay.
And then this one, what do I do first?
Well,
Plug in the 4 for the k.
Yeah, I gotta figure out what this is. So plug a 4 into k. 2 times 4 minus 3 is h of 5. Plug it into h. 1 over 5 squared. Go.
Well, 4 is on the outside. That doesn't matter.
4 is on the outside?
It's not.
All right, so look at number 1 again.
Oh, well, I'm tripping. Never mind. Yeah.
It's all right, you can trip as long as you
Yeah.
don't fall in. All right. So what about 6 and 7? Has everybody got this stuff here?
Yeah.
Will, you right?
Yeah,
All right.
okay.
It freaked me out. I was like, is something down there? Dwarf is going to take you out of the knees. All right, so the last two.
Remember,
Oh, what's up, sir?
for number 3, I don't know if I got 36. I did the 4 times 1, and I subtracted 1, and I got 39. 4 times 9, and I got 36. I guess I subtracted too early.
No, you just forgot to subtract 1 at the end. So f of negative 1. This is f of 4 times 1 minus 1, f of 3, and then that's going to be 4 times 3 squared minus 1.
Okay, I forgot it when I came back.
Yep.
The next
So here, number 6, I kind of got this one started for you. Does everybody see that g of 5 is definitely 1? Do you guys see that? And this is even better than giving me a function, because I don't have to do any work. I just got to go, they got the answer already. What do they get? 1. And what's f of 1? When x is 1, what's f? 0. Done. I really want you to understand. They didn't give us the functions. They gave us something better. They gave us the frickin' answers. I don't have to plug shit into a function because I could just look up the answer they got. That's what a table of values is answers. That's why it kicks ass to have that actually when you see that. You're like, that's harder. Oh, shit, no it isn't, because there's answers there. What about number 7? What's it say? G of f of 2. All right. So what is f of 2?
3.
Yeah, when x is 2, f is 3.
But
And what's g of 3?
8.
8. Okay. Just to show you all the ways it might show up. Yes.
So they're using different functions than the ones on top?
Oh, 6 and 7, totally.
Yeah.
Yes. 1, 2, 3 use those functions. 4, 5 use those functions. 6, 7 uses the table,
Okay.
which are totally different. I don't even know what the functions are. I just know some values. I like it. Yes.
Can we go through 6 again?
All right, so 6. So see how x, f of x, g of x, right? So what is x here? What is x?
G5.
So x is 5. When x is 5, what is g?
1.
So when you plug a 5 into g, you get a 1. I don't need them to tell me the function because they've listed the answers. I want you to really understand this. You don't plug a 5 into something because they already did it for you. They made an XY table for f and g. So what did they get when they plugged a 5 in? They must have got a 1 because that's what they put. So that actually is easier than when I give you functions because you just get the answer instead of having to work something out. Kicks ass. Those functions could have been ugly as shit, but they just put the answers down. Thank you. Hopefully. So you will see problems like that in the homework. Okay, I like it. So, turn it over. Oh, wait. Yeah, let's do a little bit more and then we'll take a break. Turn it over. So let me ask you this. See up there I've got people and their social security numbers, right? So these are some friends of mine. So if you want to use that. No. Now, if I told you somebody's social security number, could you find a way, could somebody find out exactly who that person is?
Yes.
Yes. If it's a social security number that exists, you could, if you know somebody who's a cop, or you are a cop, or you are in the Social Security Administration, whatever the shit, you have a way. There is a way to find out who that person is. If I told you, so if somebody robbed a bank and they dropped their thing with a Social Security number on it, and you've heard of robbers who rob something and they drop their whole freaking wallet and like, case solved, so you could find out who that person was, can't you? Since they dropped that number. Okay, I like it. If you found out that they had a size 11 shoe, do you know exactly who the person is? No. There's not a one-to-one correspondence between shoe size and person. But there is a one-to-one correspondence between person and Social Security number. Does that phrase one-to-one make sense?
Yes.
I have a social security number, and my social security number identifies me. I have a shoe size, but my shoe size does not identify me. Right? Oh, it's the 11 size shoe killer. Strikes again. Right? You can't go, oh yeah, that's Ted. Ted's the only guy on the earth that has a size 11 shoe. Like, no. You guys with me? So one-to-one means not only for every X there's only one Y, but for every Y there's only one X. For every person there's a social security number in the US. For every social security number there is a person. For every person there's a size shoe on your left foot, just in case you have two different size feet, right? You with me? For every person, there's a size shoe. But for every size shoe, there's not one person. There's a lot of people that have size 11 shoes, right?
Yep.
Does that by itself make sense?
J.
Good. So that means that this word makes total sense. Which murder could I solve? The one where somebody dropped a social security number, or the one where they left a shoe behind?
Social Security.
Now, shoe, maybe you can say DNA, but let's say they left a print, and you can see how big the shoe is, right? The social security number, I could work backwards to figure out who it was. With the shoe size, I can't work backwards to figure out who it was. I can get a range of perps and line them up, and do that kind of shit, but I can't figure out exactly who it was, can I? And it could have been like, I'll throw them off, I'll wear one size bigger, or something. Or I'll drop my friend's social security number, and then they'll put them in jail. I'm not suggesting it. All right, so one-to-one functions. One-to-one functions.
This is 12.1. I mean 12.
Still 12.1.
12.1.
Yeah. 12.1 is composite functions, the F of G stuff, and inverse functions. These are two basic skills you need for this chapter. So one-to-one function means that I have to be able to find a way backwards. So, for example, it's not confusing, Jeff.
Is there called inverse functions?
Yes.
Okay.
So say this is some function f of x. How do I know this is a function? Why is this a function? For every x,
It has one outlet.
there's only one y. I like it. 1 only goes to 3. 5 only goes to 2. 7 only goes to 9. Now, if I told you the answer was 9, can you tell me what the input had to be? If the answer is 9, if say f of x equals 9, can you tell me what x was? It must have been 7. Where else does 9 come from except 7? Do you guys start to see why we call them one-to-one? It works both ways. Not only does every x have only one y, but every y also has only one x. I love that. So visually, not only do you have to pass... So is this a function? Is that a function?
Yes.
Yes. Is it a one-to-one function? No, because this y has more than one x that leads to it. So squared stuff, x squared is not one-to-one. If I told you the answer to x squared was 9, can you tell me exactly the original number? No. What do you think it was? X squared equals 9. What do you think the answer was?
3 or negative 1? I mean, negative
3 is wrong. You don't know for sure. And you're like, well, it could be 3 or negative 3. Well, you don't know for sure, do you?
Plus or minus.
Right? Line them up against the wall, and they're like, can you tell? And they, oh man, I don't remember. You guys understanding? And so to tell if it's a function is a vertical line test, because for every x there could be only one y. To see if it's one-to-one is a horizontal line test, because for every y there could be only one x that led to it. So I can't, if I know the output was this, do I know exactly what the input was? No, because there's 2 freaking options. Shit. Please let that make sense. We're going to look at that a different way a little bit later so it really solidifies in your brain. So, let me see. Let's do this. Do I do this on here? No. Oh, real quick. This is relatively simple. At the bottom there, can you very quickly do what we just did with those 6 problems? Can you tell which ones are, well, which ones real quick? Can you tell me any of those that are not even functions?
A.
B.
Why is A not a function? How do I test to see if it's a function? I use a vertical line test. Does any vertical line go through that more than
It's
once?
not a function.
A is fine. A is a function. C is not a function. I love it. So just put not a function next to C. You're done with him.
Everything else is at least a function. F is.
Yeah, everything else is a function, right? All right, now you got to determine for A, B, D, E, F, which ones of those are one-to-one. So don't say anything aloud. Take a minute and figure out. And again, it's just a simple line test. You can tell visually very quickly. So a little hint, there should only be 2 that are not one-to-one. Which one is definitely not one-to-one?
B.
B. And
F.
F. They curve back on themselves, right? A doesn't do it. It's going down, and it kind of goes down a little bit freaky way, and then it keeps going down. It doesn't come back on itself, right? D is fine. In fact, can you tell me what the D function is? Something related to square root of x.
-2. Wait, no.
-4.
X plus 4. Square root of x plus 4 because it went the opposite. Yeah. E is a function we're going to learn today. We don't know it yet, but I can tell it's a one-to-one function because it doesn't come back on itself again. F does come back on itself. Oh, shit. It's parabolic. It's got no chance. I like it.
So there's a difference between a one-to-one and a function.
Beautiful. To be a function. So again, this is a function all day long. That's a function. One-to-one is an extra requirement. Okay, that's nice. Every input has only one output, but can you always go backwards?
No.
Can you be a great detective very quickly and get it done quick? No. The answer was 9. Could be 3 or -3. Shit. I can't get the answer. I can't figure out what it must have been to begin with quickly. Or at all, really, and without more information.
So basically, the function passes the vertical line test.
Beautiful.
The one-to-one passes.
And on
vertical
top of that,
and-
if it passes the horizontal line test, it's also a one-to-one function.
Got it.
I like it. One-to-one functions. Now let's see if this makes sense. I have to be able to find an inverse function if it's one-to-one, meaning a function that does the opposite. So there's a function. So watch this. Watch. Let's see. Let's graph the. Can you take a minute? And here's the function. I should just use what I had up here already, but too bad for me. Let's just graph this real quick. -1, 2, 0, 4, 1, 5, 2, 7. So give yourself a decent scale. Got to get to 7. See how this works. So -1, 2. Oh crap. -1, 2. 0, 4. 1, 5. And 2, 7. So can somebody tell me, is that one-to-one? Well, let me see. Let me not fill it in yet. Is that one-to-one?
Yes.
And let me put a little extra. Let's say that it's a straight line in between all of those, right? It's a straight line in between all those. You don't do that in general when you just have these, but I'm going to tell you it's straight lines between every point. All right, now that's a little easier. Is that one-to-one? Yeah. Every horizontal line only goes through once. can you now make a table of values for the inverse function? What does the inverse function have to do? It has to take all the outputs and bring them back to the inputs. So the inverse function is the one that is what we've been doing. If I know that the answer was 2, where did it come from? If the answer is 2,
-1.
what was the x? -1. So this now looks like this. 2, -1. So what does it do? It just
Inverse.
flips these. 4, 0, 5, 1, 7, 2. So of course I gave myself a horrible scale here. Good job, Jeff. If I could just think ahead, it'd be awesome. So 2, -1, 4, 0, and that'll be 5, 1, and 7, 2. So I can graph the inverse of a function without even knowing what the inverse function is. Because what does the inverse function do? It takes all the outputs and makes them become the input again. It undoes whatever the original function did. Isn't that what an inverse function should do? The inverse of something should do the opposite of what that thing did. So what's the inverse? Just think about it. This is an easy example. What's the inverse of x plus 2? What does that function do? It takes every input and adds 2 to it. So what's the inverse function? What's the inverse of addition?
Subtract.
All right, so what's the inverse of x plus 2?
X
X minus 2. All right, let's check that out. So notice, what's the big thing to notice here? If I have a function, if I know points for the function, what does the inverse function do? It just takes all the x's and y's and flips them. Why does that make sense? Because the inverse takes the output and brings it back to the input. That's what it does. So it just flips that table. So here, let's check this. This totally should make sense. If f of x is x plus 2, what would that look like? Can you just quickly in the air, what would that look like? X plus 2. If you graphed it, what would it look like? Slope is 1, minus 2 is going to look like that, right? It's got a slope of 1. So from your perspective, it's a straight line. Are you with me? Going up diagonally, it's got a slope of 1. Everybody cool with that? All right. Does it pass the horizontal line test?
Yes.
Oh shit, yeah. Every horizontal line is going to go through once. I like it. So it does have an inverse. So the inverse we're suggesting is x minus 2. Well, let's check this out. What is f of 3? 5. What is f inverse of 5? 3. It took 5 and brought it back to 3. It undid what the original function did. What is f of -4? -2. What is f inverse of -2? -4. It took the -2 and brought it back to -4. It undid what the original function did. You guys do this. What's f of f inverse of x? Take a second and do that. It's exactly the stuff we were doing earlier. Oh, shit, there's a reason we were doing that shit?
And we're using those functions on top?
Totally, because this is one big problem. So definitely use these guys, otherwise you can't do anything.
Oh, wow.
Yes, right? So what is f inverse? Work from the inside out, right? Just like we were doing earlier. What is f inverse? X minus 2. And what does f do to anything? I'm going to plug this in here, so I'll get x minus 2 plus 2. So what did these do? What did these do? They killed each other, and you're left with x. Why did they kill each other? Because they're inverses of each other. Right? So, how are we doing this?
How would you apply that, like a word problem or whatever?
Well, watch. You've already done this. How would I solve to get the real answer for this? What would you do to both sides to get the real answer? Take a cube root. What happens right here?
They cancel out.
They cancel. Ooh. But that's exactly what this is. Inverse functions will always cancel each other out. That's why they're called inverse functions. They are the opposite functions. They undo each other. So if I was like, stack 2 more boxes on there, and then my other boss came in and said, take 2 boxes down from there, it's back to the way it was. Right? Some of you guys probably have lived that. I remember having like 4 bosses, and one would tell me something, the other would tell me exactly the opposite. I'm like, that's me. Or if you haven't had the experience, it's in your future. How do we feel about that so far? I mean, yes?
I have a question.
Yes.
So, with the inverse function, if it's x minus 2 plus 2, how come it's not x minus 2 plus x plus 2?
All right, all right. You ready? So how did we do f of 3? What's every single step for that? What did we do? What's the very first step?
You added it.
You put 3 here.
Yeah.
Anything that I put in there is going to go right there, isn't it?
Yeah.
Anything.
Yeah.
So what is f of x minus 2? I'm going to take this and replace this with it.
Oh, okay.
So it's going to be something plus 2. That plus 2 is always going to be there, and what's that? That's x minus 2. That is how functions work. The x piece is like a blank space. And you're just waiting to see what somebody puts in here so you can put it in that blank space.
Okay.
Instead of using a blank space, we use the letter x normally to mark the spot. Here's where we don't know yet. And then somebody says 7. Oh, we put the 7 there and we do it. Yay, now we know what it is.
What's the example of when we would use this in like a real life situation or like a word problem? Like
Every time you've solved any equation, you've used this idea. I want you to understand, what is the idea of an equation? You undo what was being done, right? If you see x over 4 equals 2, what do you do? What do I do to solve this?
It's about 2 over 1 is...
What? What do you... Huh?
Yeah.
Cross multiply?
No, hell no. How do you get x by itself? What's happening to the x? Oh, so it's dividing by 4, so I'm going to attack it with the inverse function, which is multiply by 4. Now, of course, when we're learning that, why would I use all that crazy-ass language when you're just trying to learn these steps of equations? Right? But now I'm going back and saying, hey, every time we solved an equation, we used this idea. The idea of an inverse, right?
Yeah.
The reason we kind of set this up now is now you have a more formal way to go forward. Every time we learn a function, we must also learn its inverse, or else we could never solve equations with them in it. There are functions you don't know anything about yet. Hopefully you understand that, right? I don't know if anyone's ever heard of like sine function. Sine, cosine, does that sound at all familiar to anybody?
Yeah.
So that's called trigonometry. There's a whole slew of those functions that you don't know shit about. What about logs? That's coming up in our future. Ooh, everybody hates them, poor little logs. Everybody hates them logs? Okay, all right. You want to take a break right now? I think this is a decent spot for it. Come back, I guess. Come back quarter till. I'll just give you a little ha-ha. We got too much shit to do. Come back quarter till.
Quarter 2?
Quarter till. 15 minutes till. 9:45.
Okay.
That's when I'll start lecturing anyway.